Okay, we are working on 5.2.2 today. The big question of the day is, how do arithmetic sequences work? And I'll tell you where we're headed from this. Okay, our big thing is I want you to know some language of sequences. So when I say t of 3, you know what that means. And I want you to walk away today knowing how to write the equation of a sequence. And some of you did this. Actually, it showed up on our last assignment. But for example, number 1, we're going to go over it together. But the equation for number 1, this is on the back side. The equation for number 1 is t of n equals 5n plus 16. And I want you to be able to know how to write that for number 1. We'll go over that in a minute. Okay, so if you have missed any days, this is a really important lesson for you to pay attention because we're going to be getting you caught up. So let's get the laptop put away for now and focus on this because we're going to get you caught up today. All right, so we'll be reviewing a lot of the vocab terms that we've already talked about. So let's get going here. All right, so we're going to focus for most of our time today on these relatively short notes on this sequence here. So let's review a little bit from last week. First of all, can you find me a sequence generator for this? This is not being asked for any place, but we're just reviewing. Can you find me what is the pattern? What are we doing to each term to come up with the next term? You think it's plus 4? Can you guys check that for me? Negative 9 plus 4 gets me to negative 5. Can you please put that away for now? I need you focusing on up here, okay? Negative 9 plus 4 is negative 5. Negative 5 plus 4 is negative 1. Negative 1 plus 4 is going to get us to 3. 3 plus 4 is 7. Yes, I'd say our sequence generator is plus 4. We're consistently adding 4 each time. So this is the big thing from Thursday. Is this an arithmetic geometric sequence or neither? Arithmetic is the one where we add and subtract. It says, how can you tell? The way we can tell is that our sequence generator is plus 4, and it's consistently plus 4. We're adding the same thing 4 each time. Someone remind me, what's the difference with geometric? Geometric is not going to have a sequence generator where we're adding. What are we doing instead with geometric? Multiplying and dividing. So arithmetic is going to be adding or subtracting. Geometric is multiplying and dividing. And there's lots of sequences that are neither. It might start off adding and then multiply, or maybe it's adding, but it's not adding the same thing each time. So that would be neither. All right, I want to teach you some notation. It says, what is the first term of the sequence? If you look at this sequence here, what is the first number in that sequence that you see? Negative 9 is the first term of the sequence. Let me teach you some notation here so that we don't have to write out first term of the sequence. We have come up with some nice shortcut notation for this, and it looks like this. T parentheses 1 equals negative 9. If I were to see this, I would know that the first term of my sequence is negative 9. Sometimes we will pronounce this as T of 1. T of 1, or we might just say the first term. I ran out of room there, but that says the first term. So T of 1 is negative 9. They're not asking for this, but could you guys tell me what T of 4 is for our sequence? What is T of 4? Look at your sequence back up here and count and find me the fourth term. Here's the first, second, third. Fourth term is 3. So T of 4 is 3. How about T of 5? What is T of 5 for our sequence? 7. One more since you guys are doing so great at this. T of 6 is not on our list. But what would T of 6 be? How do we know that it's 11? Because we know that our generator is plus 4. Awesome. You guys are doing so good. All right. The sequence generator has a special name for geometric sequences, and that special name is the common difference. So I need you to know that term because it's going to come up sometimes. They'll be asking you, what is the common difference? And the common difference is just what are we adding each time? Now with the sequence generator, or with the common difference, we're always adding, but sometimes we add a negative. Okay, so from here on, remember on Thursday I said arithmetic sequences are when we're adding or subtracting. I want you to modify that a little bit. Arithmetic sequences, we're always adding something. It's just sometimes we add a negative. Okay? So our common difference would be negative if we had a decreasing sequence. So what is our common difference in this case? I'd say our common difference is 4. Because we are adding 4. Bless you. This is really key. Please don't miss this, okay? Guys, don't miss this because this is one of the most important things you're going to be using to do our work today and many of the problems on the test. You find the common difference by finding the difference, in other words, subtract. You subtract any term minus the term before. Any term minus the term before. That'll give you your common difference. Okay, for example, if I pick 7, what's the term before 7? 3. 7 minus 3 is 4. If I pick 3, what's the term before 3? 3 minus negative 1 is 4. How about if I pick negative 5? What's the term before negative 5? Negative 9. What is negative 5 minus negative 9? It's Monday, and it's right after daylight saving, so I'm going to use my calculator. Negative 5 minus negative 9 is, what do you suppose it's going to be? 4. So to find the common difference, you take any term and you subtract the one that came before. Did we really need that for this sequence? Not so much. Do you think that might be useful when we get to the back and we've got a sequence that looks like this? Yes. So you're going to pick one of these and subtract the one that came before it. Not the one after it, but the one before. We always subtract the one before. Okay, enough of that. Can you turn this sequence into a table for me? Sure we can. Now, be careful because a lot of people are going to want to put the negative 9 here with the 0, but is negative 9 the 0th term? No, negative 9 is our first term. So put negative 9 next to the 1 because negative 9 is our first term. Our second term is negative 5. Our third term is negative 1. Our fourth term is 3. Our fifth term is 7. You guys already told me what our sixth term was going to be. 11. Go ahead and use your common difference to find your your seventh and your eighth terms. And then see if you can work backwards to figure out what the 0th term would have been. So to move forward, we're doing plus 4. If we're going forward by plus 4, then how will we go backwards? Minus 4. So negative 9 minus 4 would get me to negative 13. We doing all right? Okay, part E. What is t of n when n equals 0? In other words, they're asking us for t of 0. This would be our 0th term, which we just found on our table. What was our 0th term again? Negative 13. So our 0th term is negative 13. All right, we're going to go ahead and graph this thing. I don't think we can graph the 0th term, but we can graph a bunch of the other points. So 1 comma negative 9, 2, comma, negative 5. 3, comma, negative 1. 4, comma, 3. 5, comma, 7. Should we connect these dots? I told you a while ago that we weren't going to connect dots with sequences. Did I ever tell you why? No? All right. Well, do you want to know? Or you want to just take my word for it? You just want to... Oh, come on. Mathematics is not faith-based. All right, so if you don't care, then don't listen, but I'll tell you why now. When I look at this graph, I can tell that the fourth term is 2, and that the fifth term is 7. Now, if I connected these, and I'm going to do this with a pencil so that I can erase it. If I connected these, then I might be fooled into thinking that there is a 3.5th term, a 3.5th term that is 1. A 3.5th term. Does it make sense to talk about a 3.5th term? Like, we have a third term, we have a fourth term. Is there a term in between the third term and the fourth term? The answer is no. So we don't connect it with a line because there are no values between 3 and 4. There's not a 3.5th term. There's no 3.1th term. So we would say that these are discrete. The question asks, should the graph be continuous or discrete? Discrete is when we have just points. Continuous is when it's connected with a curve. We're not going to get really hung up on this, but I want to ask you a quick question about discrete versus continuous. Are you ready? I'm going to give you 2 situations. One of them is continuous and one's discrete. See if you can figure out which is which. So I've got a tree in my backyard, and I go out and I measure the height of the tree every month. And I make a graph of how tall the tree is each month, okay? That's one situation. Here's my other situation. I work at a cheeseburger stand, and people come in and buy, everybody's coming in and buying 1 cheeseburger, and I'm going to graph how many cheeseburgers I've sold after each customer. Okay, one of those is discrete and one is continuous. Which one's continuous? The cheeseburgers or how tall the tree is? So for the cheeseburgers, the question would be, does it make sense to talk about the third customer and the fourth customer? Yes. Does it make sense to talk about in between that? How many cheeseburgers did I sell after the 3.5th customer? Does that make sense? That doesn't make sense at all. You can't have 3.5 customers, right? So I would say that's discrete. The height of a tree, I measured it at 3 months, I measured it at 4 months. Would it make sense to go out and measure it at 3.5 months? You could measure it at 3.5 months, and it's going to be somewhere in between how tall it was at 3 months and 4 months, right? 3.5 months makes sense. 3.5 customers doesn't make sense. You get why one of them's discrete and one of them's continuous. So anyways, that's all extra information. I'm not going to test you on that. It'll come up again though. All right, let's write an equation. So I'll show you what our equation is going to look like. It's going to be T of n equals something times n plus something. And I'm hoping that this makes you think of something that we did in first semester. What does this remind you of? Y equals mx plus b, and it's the same thing. It is the same thing. We're using, instead of y, we're using t. Instead of x, we're using n, but it's the same idea. This is still going to be our change, which we're now calling our common difference. What is our common difference again for this one? Oh, it was 4. And this is still going to be our initial time, or initial value, so which would be our 0th term. We always start when x was, remember how we always started when x was 0 before? We looked for 0 in our table. We're going to be looking where n is 0 now. And our 0th term, according to our table, was negative 13. So plus negative 13. And if I were writing this out, I would probably write it as 4n minus 13 instead of plus negative 13. We're going to skip the domain. We'll come back to that later. This last question is kind of important. It says, how is the common difference related to the graph? Our common difference was 4. What does 4 have to do with this graph? How far apart vertically each dot is. Like if I wanted to go to this next dot, I would need to go up 4 and over 1. What does that make you think of? Rise over run. We had a fancy name for that back in Unit 2. Slope, yeah. Common difference is basically slope. We could put a 1 underneath it. It would become 4 over 1, and that would be our slope triangle. So common difference is related to the slope. All right. Flip over on the back. I'm going to go over a couple of these with you. And I'm going to ask you to finish the rest of them up on your own. We're going to go over number 1 and then number 7. And then I'll leave you guys to it. You guys with me? Can you pick your head up, please? Thank you. All right. Number 1, I am telling you that all of these first 6 sequences are all arithmetic. But confirm that for me. What is our common difference here? It looks like it's plus something. Plus what? Plus 5? So our common difference is plus 5. And it's consistently doing plus 5, right? Remember, to write our equation, we need the common difference and we need the 0th term. Now, the 0th term is not on this page. This is the first term, second term, third term, fourth term. The 0th term would actually come before the 21. So we're going to have to work backwards. If we do plus 5 to go forwards, what are we going to do to go backwards? We'll do minus 5. So start at 21 and go backwards, do minus 5. That would get us to 16. So our common difference is plus 5. Our 0th term is 16. I don't know why I'm writing it out as 0th term. I should have written that as t of 0 equals 16. That's way faster. At any rate, we now have everything we need to write our equation. It's just like y equals mx plus b. We're going to write it in t's and n's instead of y's and x's this time. So there is our final equation. And remember, this was one of our big learning targets for today is if I give you a sequence, can you turn it into an equation? Now, we haven't done this last piece yet. Can I get your attention when we go over number 7? We haven't done this yet, but it's okay. Don't worry about it. We're going to find the first 5 terms. 1, 2, 3, 4, 5. And keep in mind that our first term has t equal to 1. Or sorry, n is equal to 1 here. N is equal to 2, 3, 4, and 5. There's a couple ways that we can find this. Anybody want to guess what the first term is? I heard 12, I heard 24. I haven't heard my favorite mistake yet. What do you think the most common mistake answer would be for this? A lot of people are going to want to say 18 because they're like, oh, that's my starting value, right? But remember, that's not my first term. That's my 0th term. So my 0th term would be 18, and then I would do plus 6 to that to figure out my first term, which would be what? 24. Another way that I could find the first term is to just plug 1 in for n here. 6 times 1 is 6, plus 18 is 24. If I want my second term, I could just plug 2 in for n. Or I could just keep adding 6 each time. Let's just keep adding 6. 24 plus 6 is 30, plus 6 is 36, plus 6 is 42, plus 6 is 48, and we're done. Are you guys all okay with why I was adding 6 each time? Yes? All right. Hey, I got one last question for you. You guys with me? One last one. For number 7, what is my 100th term? Oh my gosh. Would that take a long time to find? It could if we started at 24 and we kept adding 6 plus 6 plus 6 plus 6. We'd have to do it 100 times. Well, 99 times. What's a faster way to find the 100th term? We could just, remember this is n. We could just put 100 into this equation right here. What's 6 times 100? 600 plus 18 is 618. You get how we did that? If they asked you to find the 1,000th term, could you do that pretty quickly? Yeah, totally. Hey, I got some typos on here. In 8, 9, and 10, all of these t's should be n's. I screwed that up. All those t's should be n's. All right, folks, I would love for you to finish up 1 through 10. 11, 12, 13, 14, that's just if you want a little bit of extra challenge. I'll tell you that those ones are all geometric sequences, so they're different. Give them a try if you'd like. I'll put answers up on the screen here in a moment, but I want you guys to give these a shot. Focus on 1 through 6 first, okay? Get my attention if you need some help. We'll come back and chat about these in just a moment and take some notes. Let me give you about 5 minutes on this. Again, my main priority is that we're good on 1 through 6. If you did not have a chance to get done with 7 through 10, that's all right. Our main learning target for today is if I have a sequence, an arithmetic sequence, can I write an equation? How are you guys feeling about this? Can you show me on your old thumb meter? Are we feeling like, give me the test right now? We're like, yeah, a little more practice will do me some good. Or I have no idea what's going on. How are we feeling? No idea? Okay. Ask a question. Ask a question. Anybody have any questions? I'm seeing a lot of thumbs in the middle, and that's good. That's good for a first day. Some people are real confident, and that's fine too. Can you guys handle being okay? It's for after the bell. You don't need now. For anybody who tried the last 4, these are the answers. I'm not going to get too deep into these today because we're going to be doing these tomorrow. So if you didn't even get a chance to look at these, that's fine. If you tried them and you got wrong answers, no biggie. I'll show you a couple things tomorrow and you'll be able to do these like a pro. Okay, we're going to take some notes. Can you guys open up your packets to your vocab sheet, please? I want to add a couple of things to our vocab. And then we're going to be taking some notes in the next page in the arithmetic sequence column. The first thing I want to do is add something on to our arithmetic sequence notes. By the way, if you were absent at all last week, then you're missing some important vocab. You're going to want to borrow someone's packet to get that missing vocab. We're about, I'd say, 2/3 of the way down our page at this point. I want to add something really quickly. If we find a sequence generator that is plus and it's an arithmetic sequence, today we learned a new name for that sequence generator. Do you guys remember what it was? It's only if we're adding. Well, it is an arithmetic sequence. This one starts with a C. It's actually 2 words. The first word starts with C. Common difference. Then the reason they call it a common difference is how you find it. How do you find the common difference? You take a term and you subtract the one that came before it. Question? You can take a picture of it at the end of class, yes, but not on the screen, please. In a moment here, I can also give you a copy of one of my packets, and you can get it down. We'll have some time. All right, we will be learning another name for when we're multiplying by something. So leave a little space there, but I'm not going to tell you what that is just yet. It is common something, but I'm not going to tell you just yet. We'll learn that later on. The only other vocab I want to add today is the word term. When we're talking about a sequence, our sequences are made up of terms, and a term is just a value in a sequence. This is on the vocabulary page. I'm putting mine on the vocabulary page. You can put it anywhere in your packet you want. I'm going to give an example of a sequence here. How about 21, 26, I think this is one that we did today, 31, 36, ... So I just want to put some quick notes on how we name these things. 36 is the fourth term. But we don't have to write out 4THTERM each time. There's a shortcut to this. We learned the shortcut for this today. What can we write instead of writing out fourth term? We can just write T of 4. So our fourth term is 36. T of 4 equals 36. So when we see that, we think in our heads, oh, I know that the fourth term is 36. 26 is our second term. So the second term, we would write T of 2 is 26. That's going to be it that I'm going to add to this page. But we're going to add some stuff onto the next page. So as soon as you get those couple things done, go ahead and flip over to your next page. We have learned a lot about arithmetic sequences. In fact, we're just about done learning about arithmetic sequences. So that first column on the next page, I want to fill out most of this. So let's talk about arithmetic sequences. So on Thursday, we learned that arithmetic sequences are special sequences, and what's special about them? Generator is addition, subtraction. That's what makes an arithmetic sequence special, is that it has addition or subtraction for its generator. And specifically, we can always write it as addition. Subtraction is just adding a negative. We have a special name for our generator if it is something that's adding, and that is our common difference. I want to make myself some notes on how to find the common difference. A lot of the times you're going to look at it and your sequence goes 5, 10, 15, 20, and you don't really need to think too hard about what's going on. But sometimes your sequence has some big old decimals and you're going to run into some where it's fractions. If you two can't handle sitting together, can you move back to your other seat, please? Thank you. It doesn't seem to be working out too well. Sometimes you're going to have decimals or fractions, so I want you to know how to find this. Plus, I'll tell you that when we move this over to geometric, it's kind of the same thing. So let's get this written down. So how to find. How to find a common difference. It's pretty easy. You just pick any term. Any one you want. And subtract the term before it. But you got to do the one before it, not after it. If you do this in the wrong order, you're going to get the common difference, but it's going to have the wrong sign on it. It'll be positive where it should be negative, or it'll be negative where it should be positive. So let's give ourselves an example here. Leave a little space above this example so that we can do our work to find our common difference. So I'm going to use an example that was from that sheet that we just did. The sequence began 75.2. That was our first term. And then 62.5. And then 49.8. And then 37.1. That's all they gave us. Does this look familiar? You guys remember doing this one just a few minutes ago? ... So if I wanted to find my common difference, I can pick any of these terms that I want. I think I'm going to choose this one and subtract the one that came before it. So what I would do to find my common difference would be 49.8 minus 62.5. And I would grab my calculator and put that subtraction in. (49.8 minus 62.5 is negative 12.7. Did I have to pick those two? Nope. I could have picked 62.5 and then subtracted this. 62.5 minus 75.2. I could have done that instead, and I would have gotten the same answer. Or I could have picked 37.1 minus 49.8, and I would have got the same answer. It doesn't matter which one I pick, but the important thing is you've got to do something minus the one that came before it. If I switch this, and I did 62.5 minus 49.8, do you see what I'm getting? Is that the correct common difference, 12.7? No. So you've got to take a term and subtract the one that came before it. That's key. Okay, and when we get into geometric sequences, this is where people are going to make mistakes. They're going to do the one that came after it instead of the one that came before it. You guys got that? Pick a term, subtract the one that came before. All right, what else do we need to know about this? So we found our common difference is negative 12.7. Let's make a table. N and T of n. And sometimes when we do our table, sometimes we'll put the 0th term in there, sometimes we won't. Remember that the first term in the sequence does not line up with 0, it lines up with 1. So 75.2 would go here. 62.5 is the second term. 49.8 is the third term. 37.1 is the fourth term. We've already figured out that our common difference is negative 12.7. The other piece we need for an equation would be the 0th term. What's our 0th term? We're going to have to work backwards to find it. So we'll do plus. We'll do the opposite, plus 12.7. And 87.9 sound right? 87.9. So we had to do a little bit of work to get there. But once we've got that 0th term and our common difference, then writing our equation is really simple. It's just T of n equals, in this case, it's going to be negative 12.7n plus 87.9. 0th term goes at the end. Common difference gets attached to the n. So we've got an example of a sequence, how we found the common difference, how we turn it into a table, how we turn that into an equation. One last thing while we're here. What is the 100th term? Is this going to be hard for us to find? Not now that we've got our equation. The 100th term is just t of 100, which means take your equation, stick 100 in for n, and then work it out. If it's got decimals and big numbers, feel free to use your calculators. I think we could probably pull this off without a calculator, but yeesh. All right, that comes out to negative 1,182.1. All right, and that's our notes for today. I'll get you guys your assignments. I'm going to need someone to help me pass this out because we're running short on time. Can I get a volunteer, please? Pretty please. Please, please, please. Otherwise, we're not going to have time for me to show you your test, guys.